be discussing today on one case study, which will try to show you that how this cloud to things paradigm, right, cloud, fog, edge and Internet of Things, how this whole paradigm works in a integrated fashion, right. So, it is primarily of Internet of Health Things, that is a application related to the health application, though the application per se may not be totally medically proved, right. That means whether or I should say there may, in order to deploy, you may require a lot of other things, but nevertheless it shows that how this sort of application will be there. So, primarily we will be looking at cloud, fog, edge, IoT framework as a whole, or what these days we say that cloud to things continuum. That means it is not separated, but rather it is a integrated things, right. So, you cannot say that only I manage this the IoT or edge or fog or cloud. Now, in present day situation you need to look into the whole thing in a more holistic fashion, more integrated fashion. And as we will be looking at a case study on Internet of Health Things, so that is the one work which we did in our lab. So, that will show you that how things can be done. So, this is the thing. So, what as we are discussing, so it is primarily a case study on cloud, fog, edge computing for Internet of Health Things, right. Okay. So, what we have seen in this course, or overall, that there is a service, that cloud computing, which provides different type of service on a subscription based, right. That means you subscribe for that service, right. So, that like it can be infrastructure as a service, it can be platform as a service, it can be software as a service. So, you pay as you go type of model, right. And it is theoretically infinitely scalable. That means, if you go on demanding it, go on increasing the resources, and in both sides, that means you can go on acquiring resources, you go on releasing resources, and also it is ubiquitous, right, like anywhere, everywhere it is available. The major challenges what we faced in this cloud thing, what we can perceive is that you require a good connectivity, right, quote unquote good connectivity. That means, you should be always connected when you are there, and that is one part. Another part is that anything it has to go to this cloud and come back, right. So, this there are several service providers these days. We have many service provider, to name a few of them, like Amazon, Google, IBM, Microsoft and many others, right. And you can have your own organizational cloud or community cloud also. So, in other sense, so how these service provider maintaining those cloud, their infrastructure, they need to have some infrastructure, right. So, they are maintaining across different geographical spread, or what we say that more this cloud data center or CDCs, right. So, there are data centers across the things. So, now your this traffic, say I am sensing the temperature of this room and want to see that whether the temperature within this limit, then that I need to collect by some IoT devices, right, or some sensors which collect these things, push it to this backend cloud wherever it is, and it takes a call based on that what is the temperature required for a, say, so called studio like this. So, it takes a call and then revert back whether temperature normal, or AC needs to be switched on or needs to be switched off, or temperature needs to be increased, and type of things, right. So, what we see that this add to this latency, and some of the things like as I mentioned earlier also, this could have done in a much lower level, right, or need not have to travel so much. There could have been a device or the network device in this which is connected with the sensor nodes, could have taken a call, because this may be a trivial thing that this temperature is within the things, or in other sense, or at least it can aggregate this thing, like instead of sending all these if there are 10, 20 sensors, not all the sensors, but say average or some sort of a average along with the mean, along with the variance and type of things, it can send that this is the situation of this temperature in this room, and the first of all the data load is less, and it also do some downline the calculation. So something at the edge could have taken a call, right, or something what we say that maybe at an intermediate level, maybe the IIT Kharagpur router, which is not in this particular department, somewhere else in this institute, could have taken some decision on that whether the some sort of actuating is required, etc. So, at the fog level, and then if something is required, or this aggregated thing could have gone into the cloud level. So, we can have this multi-tier things, right. So, so that I am not going into the again the full details. So, fog, as we have seen, takes the cloud closer to the data producing sensor devices such as routers, servers, switches, etc., which act as a fog nodes if the processing power is employed for the data processing and result generation. So, intermediate things can act as a fog node. So, what so use of fog technology for real time or near real time, so that your overall latency to traveling to the cloud data center and coming back may be reduced. Aim to develop a fog based healthcare model in this particular case study, what we try to do. So, collect data at the edge devices to reduce latency, network usage, overall things, right. So, there are a lot of advantage once you bring the things to the edge, right. So, that means you are less latency, so your turnaround time is less, and you can better usage of the network bandwidth. There is no unnecessary wastage of network bandwidth, and overall cost incurred in the cloud may be less at doing the things. The other side is that your edge devices should be smart enough in doing this, right. That may be a resource requirement at the edge. Had it been cloud, you just send it and forget it, right. Not forget it per se, but it is the responsibility on the things, right. So, whereas when you bring it to the edge, those edge devices should be smart enough to handle those things, right. There are as these days the edge devices are becoming smarter, even whatever the switches, etc., we buy these days, at least at the organization level, are much more resourceful, doing lot of processing. So, there may be a issue, or there may be a chance of having a better performance using this edge and intermediate fog and the cloud. So, this some literature or from the internet we have taken this picture, the references are at the end, but what we see the overall. So, at the cloud at the top level, right, then we have fog nodes, then we have that edge layer, and then we have these IoTs or the that at the bottom layer, right. So, so what we see that mostly this cloud is mostly involved in more of a so called business analytics and intelligence. That means, they are doing at the much higher level. So, doing something at a much higher level of business analytics and intelligence at the cloud level. And then we have this fog layer, which is down below, which is more which is leveraging on local network, data analysis and reduction of the control response, virtualization, standardization. This can be instantiated in this fog layer. So, it comes down. So, you can have some sort of a low level data analysis and things like that. Rather, these days what we are looking at, not only the fog nodes or more of a fog network, which can communicate between themselves to take a call, right. And once we come into the edge, because of this huge volume of IoT related data or being sensed and pushed to the cloud. So, the edge may be a smarter way of that some sort of a real time. So, large volume of real time data processing at source, more or less. So, it is at the edge. On premise data visualization, some industrial PCs, embedded system, gateway, micro data storage, all those things can act as a thing. And at the down the line, we have the sensors and controller, where at the data is being are being originated from, right. So, we have all these 4 layers, and if you see, these are not isolated things, right. These are not isolated in the sense not that they are definitely connected, but isolated in the sense they are processing, say what say at the edge level processing is going on, that is related to that what processing the fog layer will do, that is related to the cloud and other way around, right. So, this overall system should work in appropriate what we say proper orchestration, right. Otherwise, the overall gaining this overall efficiency in terms of say latency, in terms of energy, in terms of say some sort of a real time application visualization and other things, that may not be feasible unless they work in a integrated fashion. So, what these days are more what we look for is more of a cloud, what the term basically you find in a cloud to things continuum, right. So, it is a integrated framework rather than a piecewise layers, right. So, rather if some of the other things are also becomes important, see if the information is being percolated. So, at the ground level when the information is going up, there is a issue of what we say compromisation on the privacy of the data, or rather if I take this data to the end, then I know that at different layer I know that where the data is generated, what type, even what type of sensor, etc., different type of. But if I do something at the edge of my own network, so I am forming some aggregation, so that my automatically if there are some sensitive informations, those can be protected, right. So, in going out of the network, in number of cases that may be a issue, though as of now we want to look it more of a in terms of that how good in this in terms of energy, in terms of say what we say network delay and so on and so forth, right. So, those are the things which are more things. So, if we see in this sort of a integrated fashion, this may help me in a better management. So, the same thing if we now see this hierarchy, at the end of course, the sensings are there. It may so happen this your at this IoT devices and these edge devices, means IoT devices itself can have some computing resources, and it can be able to push those thing at the up in the line. So, as we are discussing, so the limitation, or I should say the challenges in cloud is that the latency in several cases is pretty high, large volume of data being generated at the cloud level, means at the sensor level, and which are need to be transmitted to the things, and it in turn requires more network bandwidth, right. So, not only the network delay, the network bandwidth requirement is also high in order to have appropriate response time, right. So, these are the serious challenges, though the cloud do have enormous computing ability with definitely a huge support on the storage side. So, that is not may not be a major issue, but these are the serious challenges, especially for applications which are which demands real time or near real time response time, near real time responses, right. So, if we look at the other side, at the edge of the thing is the IoT devices. So, their challenges are definitely the processing power, they have a limited processing power, storage, power requirement, and at times they do not have a global view of the things, or at least a more larger view of the things, right. So, for example, that say if I consider a large room with 10, 20, 10, 20 temperature sensors, and say one sensor saying that the temperature, or say 2, 3 sensors, one corner of the things are saying temperature is normal, whereas the other end there may be some challenges due to some there may be some due to some say heating effect, due to maybe for the servers or some other things, and the temperature is not normal, right. Now, individual sensors are looking as their own small region. So, it may not have a more so called global view of this room, that how overall things are there. But if I could integrate this whole set, right, this 10, 20 sensors, and go little higher level, that the switch which is connected with these things, or the server which is connected with the switch which is connected, which is basically accumulating the sensors of this room, that may take a better call of the things, right. It may see not only the individual sensors, but also see that what is the different mean, median or mean and variation of the temperature within the things, and if that is beyond the model which to be there, it can do. So, this is a very may not be a very what we say complex example, but there we can do in we can see that there are need of a little higher level of abstraction of the things, right. If I go little more higher level, like all the labs of this building, all the labs of say institute, then I may go little more higher level, maybe at the IIT Kharagpur router end or things like that, and then we can take a better call of the thing, right. So, what we see, this is the same this hierarchical layer helps me in reduced latency support for real time applications, right. So, if I can make this type of fog and edge computing in between, so it can support less network congestion, because if more traffic are going at the more towards the cloud, so it is a tapering and more network congestion, and may reduce the cost of execution at cloud, right. So, cloud you need to pay, it is a subscription model as we know. So, you have to pay more, and if it is down the line, then it is already a resource which is surplus in my premise, and we are exploiting that. And better handling of some colossal data and generated by the sensors, and this means cleaning and other things, more of data location aware things, right, more of location aware application and things like which are more location aware stuff, right. And of course, there are issues which are related to the data security and information security which can be. So, this hierarchy level really helps. And if we look at this particular say what we say this demonstration or this case study, what we are going to discuss in more details is a fog edge cloud fog edge IOHT, that Internet of Health Things overall framework. The overall objective of the thing was to design a fog edge computing based health model to reduce latency, network uses and cost incurred to the at the cloud, right. So, whether we can have this for health related applications, to test and design the fog model using iFog. So, we used a iFog simulator. So, this simulator to have a simulation. So, what we usually try to do, that once you try to realize things before going towards the hardware, you want to see that how is the feasibility, and the simulators really comes handy, not only here in different applications. And then we tried to develop a customized wearable device for collection of the health parameters, and to implement the proposed model over hardware and test its efficacy, right. So, that whether we can have a hardware to test to study the DUE based computing and study its efficacy in the proposed health scenario, right. So, whether we can have a DUE based computing framework and propose study the efficacy in the health things, right. So, couple of things which come up. One is that we want to see that whether this type of this integrated thing to implement, and see that how whether they are efficient for say cloud only type of scenario type of things, right. And then have a simulation environment, and then go for a hardware implementation, and then to have another that DUE computing concept, we try to look at those type of things. So, if we look at the overall workflow of this over this particular case study. So, conceptualization and the modeling, designing and implementing the fog model, followed by performance evaluation using iFog sim. So, just to by a simulator, that is the iFog sim simulator, to just see that what is the how the whether the model is workable or not. So, results and inference from the simulator. Then we try to make a hardware implementation of the simulated model, including fabrication of a customized body sensors and activity using accelerometer and what we say heart attack alert, what we say, but to make it very clear that it is the type of algorithms or type of things what we want to do, it is has no medical and clinical implication and has been used only for a demonstration purpose, right. So, it is only for a case study we did. So, actual things is requires a lot of other things like domain knowledge from the doctors and things like that, all those things will be required. And then activity detection and using accelerometer and this that activity detection, that means whether we can have some of the things like accelerometer gives you that the some notion of the movement, and there are other health parameter gives some other notion. From there whether we can converge to a things that where what is the going on. And then results and inference, and we also proposal for a due framework what you will share, and then inference from the whole thing, right. So, primarily want to look at a motivating case study and see that whether by using this sort of arrangement whether we can have a whether we can have a efficiency in terms of say delay, overall costing, bandwidth utilization, energy and so on and so forth. So, this is the simulation using this iFog sim simulator. So, though if you are interested you may download the simulator, it is a open source, rather iFog sim was initially the base version was developed in a collaborative thing with IIT Kharagpur and University of Melbourne. So, and later on now is being maintained by University of Melbourne for this fog simulator and being widely used by different this particular this cloud fog edge community. So, here you have, so I am not going into these details of these because this is more related to the simulator, but definitely you have different component like module placement, mapping, module placement, and then fog device, this edge app and application controller circuit and things like that. So, you can have a simulator which can work, and we also looked into this type of hierarchical topology, where at the down level you have that IoT devices. For our case study is IOHT, so Internet of Health Things. Then at the other end you have the cloud or the what we call level 0. Intermediate there are fog devices, it may be the area gateway or the ISP area, these are the area gateway, and then we have the edges. So, it is layer wise. So, at the top layer 0 is the cloud, then we have the fog layer, edge, and then the IoT. So, this is a this way it can be realized. So, that what we look into is the network topology in this fashion, and we use some typical configuration cloud, fog, edge, IOHT. So, typical configuration. So, if you see that if we have this cloud, ISP, area gateway and mobile. So, different type of things, and then what we see that the cloud is definitely more resourceful like in terms of say MIPS or RAM or even this overall power and type of things, it is much resourceful. Whereas, if I see this mobile age devices, these are less resourceful, but nevertheless what we see that if we look at an integrated fashion, then we can have a better response. So, source are body sensors, mobile, area gateway router, ISP, mobile device for the display when it returns back to the things, like I say a alert and then I return back to the device for the things, right. So, this is the latency sources. So, where it will be delayed and things like that, and we taken some references, like if it is a cloud, the latency is the maximum because you need to travel a much further distance, and whereas if it is the edge in the mobile or these body sensors, the minimum latency. So, it is very near and it may be the minimum latency is there, right. So, in this case what we use is the mobile as your as collecting the data from the sensors and then pushing it to the rest of the things like fog and things, we will come to that. So, and also mobile is used as a, as we are telling that it is giving some sort of a alert. So, the alert is displayed on the mobile device that health related alert, that it is normal or you need to visit a doctor and things like that. All those alerts are provided in this using this mobile device. So, if we look at the overall workflow, so one side is the body sensors or the which is collecting information from the body for this particular application, because it is a what we saw Internet of Health things with the body sensors. Then the client module, then the data filtering module, then we have data processing module, event handler module, cloud, and it comes back to the cloud module and the display of the things, right. So, this is the path, and there may be a confirmatory module that if you are predicting a event, then who will confirm it? It may be confirmed with the with some other knowledge base or type of things which may reside in the cloud and things like that, right. So, or rather if there are things, it is reporting that logging the data there for further use. So, if you see this is the overall flow of the things, like how the process flows. So, it collects data and put to the client module which may be in the mobile, then put the data filtering module with the next step in the fog nodes, and data processing also can be done in the fog nodes, or it is pushed to the cloud and then come back into the thing. There are several other things like you need to data cleaning and things like that. It is not that the data are all directly fed into the processing unit. So, if we look at the application placement, the client module is placed in case of a fog based model in the mobile, and in case of a cloud based model also in the mobile devices, right. So, the client module, that is what we here we are considering as edge, whereas this the data filtering module, that is area gate, it is placed in the area gateway, whereas in case of cloud only scenario, it has to be pushed to the cloud, right. And data processing module also in the area gateway, can be at the area gateway, or in the cloud only, it will go to the cloud. In case of event handling module, it can be in the area gateway. So, that is much lower or much nearer to the source, and we have on the other sense, other than the this edge or the where it is sensing, all in the cloud based model, all are pushing to the cloud, right. And the confirmatory module is both the cases cloud. So, what we see that in case of a this edge, fog, cloud type of things, that is distribution of the work is there, whereas in the cloud only module it pushed to the cloud. There are one way it sounds pretty efficient in the terms that I bring it down, but definitely you require resources, you require proper orchestration of the things, how much to be calculated here, and a double labor and hierarchy type of things, who will respond to whom and how things will be generated, where it is if it is a like virtually some central place like cloud, then it takes the call overall. That is there is a challenge that in the terms of a resource and things like that. And then there are also involvement of processing, etc. So, though we do not bear the cost of the cloud, but there are some of the costing out here also. But nevertheless, what our say proposal is that, as if you are having resources which are surplus can be utilized, so this can be there. And of course, this configuring this edge for cloud type of infrastructure is much more complicated than a cloud only scenario, right, because that is already there. Here you have lot of loading on your on the part of the individual or the organization to set up this type of things, right. So, so let us stop the discussion here, and rather in the subsequent talk or the subsequent discussion or session, what we will do, we will continue with this and see that how keeping these premises, how we achieve the this IOHT for edge for cloud type of paradigm, which allows us to have more efficiency in which allows us to have better efficiency in terms of say latency, in terms of bandwidth utilization or network utilization, in terms of overall costing, other things, right. Okay. So, let us stop our discussion here. Thank you.